Welcome to the deep dive. We love finding that perfect intersection of high technology and just real world application.
Absolutely.
And today we're taking a deep dive into something I think is genuinely revolutionary. It's a university research project that is completely redefining what a science lab looks like.
And more importantly, who gets to be a scientist?
Exactly. Our sources explore this really innovative system. It's called the Online Bird Buddies project. So our mission today is to unpack how a simple bird feeder, but one equipped with some pretty cutting-edge AI, is turning students' backyards into labs.
And we're talking about backyards all over the globe, right? This isn't just one campus.
Not at all. Whether they're in, Arizona or rural Costa Rica, these are fully functional, remote, and accredited research laboratories.
Incredibly.
So the core question we're tackling is, well, it's pretty fundamental. How is this high-tech, decentralized approach changing the actual definition of hands-on science?
Right. What are the challenges when you do that? And what are the incredible scientific opportunities that pop up when you tear down the physical walls of the university lab?
That's the heart of it.
Yeah. And this is such a perfect example of what accessible AI can do for research. This deep dive shows us how sophisticated tech is being deployed in the most common settings: a backyard, a porch.
Right. Anywhere.
And it's used to gather specific, verifiable, and this is the crucial part, publishable data. Data on biodiversity, on animal behavior, on geographical variation. It really democratizes the whole act of generating scientific knowledge.
Okay, so let's unpack the mechanics first. How does this actually work?
So the project is running out of Arizona State University. It's part of their online undergraduate research scholars program. They call it the RURS program.
Right, RORS. And it's led by Professor Kevin McGraw of the School of Life Sciences. He must have seen that remote students are this huge untapped resource for data collection.
That's it, exactly. And the technology is what makes it all possible. It's not just, a webcam pointed at a bird feeder.
No, it's way more than that.
The key is the AI-equipped feeder. It's got a whole camera package inside, and it connects through an app right to the student's phone or tablet. It's basically a remote sensor designed to capture photos and videos of every single visitor.
Okay, but the real intellectual leap, for me anyway, is in the feedback loop. The sources mention something called a postcard. What is that? What does the AI give back to the student?
This is where the learning just accelerates so dramatically. So after the system captures a visitor, let's say it's a specific type of finch, it doesn't just log the picture.
It does more.
It sends an immediate postcard notification to the student. And this digital postcard has an instantaneous ID of the bird, plus all this great contextual information. Its species history, migration patterns, common behaviors.
Wow, so that completely changes the pace of learning.
Totally.
In a traditional lab, that ID process, keying out a species in a book, that could take hours, days even. But here, the AI does the routine identification, which frees up the student to focus on the real science questions, the how and the why of the behavior, not just the what.
Exactly. It just bypasses all that entry-level grunt work.
Yeah.
And it lets the student jump straight into higher-level critical analysis. The AI is kind of like the research assistant that speeds everything up.
Which has to be invaluable when your students are spread out so far apart.
Oh, absolutely. And the geographic scope is something else.
We have to talk about that scope, because the first semester alone showed this massive reach. And that's where I start wondering about logistics.
Well, if you look at the bigger picture, the diversity of locations is just stunning. I mean, students are running these labs from 8 different places mentioned in the sources.
All over the U.S., right?
Spanning the entire country. Arizona, Washington, Florida, Wisconsin, Virginia, New Hampshire. But then it also goes international. They have students in Hawaii and even participants down in Costa Rica.
That's incredible. But, that reach also raises some immediate scientific questions for me. A feeder in snowy New Hampshire versus one in tropical Costa Rica. How can you possibly standardize that data?
That's a great question.
Isn't the lack of control in these super diverse environments a huge threat to doing publishable science?
It's a critical challenge, and it's actually why the AI is so important. The system helps normalize some variables, things like light and camera angle. But the scientists leading this, they know the data shouldn't be standardized geographically.
Oh, so that's the point.
That's the whole point.
Yeah.
The goal is to capture hyper-localized biodiversity data. The variation is the research.
So you're not trying to compare a robin in Wisconsin to a tropical kingbird in Costa Rica directly?
Not directly, no. The goal is to see how those local conditions, the climate, the competing species in Hawaii, whatever it is, how that impacts behavior within that local ecosystem. It's a shift from general science to very specific applied ecological data.
Okay, that makes perfect sense. The diversity is actually the independent variable.
You got it.
This is where it gets really interesting, though, because, I mean, the scientific method is all about experimentation and adapting, and the sources are filled with these great examples of students whose first hypothesis just got, blown up by reality.
Which is the best kind of learning experience.
Oh, it is. It forces them to pivot, and that's the core of what we want to look at.
Because the difference between just watching birds and being a scientist is what you do when your first plan fails.
Yeah.
That pivot is probably the most valuable lesson here.
Okay, let's start with case study A. This one takes us out to the Pacific. Mason Margan, a student in Hawaii studying conservation biology and ecology.
Right.
His initial goal was, well, it was pretty textbook. He wanted to study native Hawaiian birds and their feeding behaviors.
And then he encountered an adversary that just immediately derailed his very neat academic plan, the Java sparrows.
Huh. And these were not polite visitors, were they?
Not in the slightest.
The detail that I find both hilarious and scientifically crucial is how aggressive they were. They were so efficient that they ate all the food by 11 a.m. every single day.
Every day. It made his initial plan, which was studying habits based on time of day, completely impossible.
He even said they don't discriminate with food. They just destroy it.
It's the scientific equivalent of your computer crashing the moment you hit save. But instead of just giving up, Mergen showed this real scientific resilience.
So what did he do?
He used the footage of this feeding frenzy. He talked with his classmates, and together they shifted his entire focus to the bird's territorial aggression.
Ah, so he pivoted. He moved from a passive measurement of, who eats what, to an active investigation of competition and control.
Exactly. And his new findings confirmed that pivot was the right move.
Right.
He observed these Java sparrows were, in his words, super territorial.
And they won't let any birds come to the feeder at all.
That's right. They weren't just hungry. They were actively monopolizing the entire resource. It's a totally different research question.
So that's a shift from ecology to, ethology, the study of behavior.
Precisely.
Yeah.
And now his current research is built on that initial problem. He's actually running an intervention. He's investigating what happens if you temporarily alter their feeding environment.
To see if it changes their territorial behavior.
Yes, to see how it impacts their resource guarding.
Yeah.
He went from just observing a problem to actively designing an experiment to understand it. That's sophisticated fieldwork.
And that's a level of critical thinking you just can't get from a textbook. Okay, now let's swing over to the Midwest. Case study B, Alex Van Hoof in Wisconsin.
Right.
Also studying conservation biology and ecology. But his challenges were less about aggressive birds and more about the raw, practical logistics of just setting up a field site.
Yes, his initial struggles are something any field scientist would recognize no matter what they study. He admitted, I had never fed birds before.
So he had to become a problem solver first.
Absolutely. He had to figure out how to fight off squirrels, which is a classic problem.
The eternal enemy.
Then he had to learn the nuances of the feeder software, experiment with different kinds of feed to attract the right birds, and find the best physical spot for the feeder, which, is often the most overlooked part of collecting good data.
We always focus on the flashy tech, but the ability to just successfully manage a remote sensor and fend off squirrels, that's the skill that gets you a job in conservation.
It absolutely is. And once he mastered all that hardware and the local logistics, he was able to launch a really classic controlled experiment, a comparative study.
And what was his research focus once he had everything running smoothly?
Van Hoof is using 3 different types of bird feed at the same time.
Ah, to see which birds prefer which food.
Exactly. It's a really focused, measurable, and repeatable experiment that generates clean, comparative data on foraging behavior, all happening right there in his backyard.
That's just elegant in its simplicity. It's a perfect example of how you can get publishable, quantitative results from a really accessible setup.
And, the way he talks about it, his value statement, it just underscores the educational impact. He realized he was gaining tools for his future career. He called the program a phenomenal experience.
He's not just learning theory, he's running a real research project from his window.
That's it.
So what does this all mean for the academic world? I mean, the sources suggest this is a lot more than just a cool pilot program. It seems to be fundamentally shifting the learning paradigm.
It really is. And this gives us critical context about the educational and even personal liberation the IORS program offers. Professor McGraw said the program has been fabulous. He explicitly stated it went way beyond his initial expectations.
Both for data quality and for how engaged the students were.
Exactly.
So let's dig into that institutional shift. How does this challenge the traditional idea that, top-tier research has to happen inside a multi-million-dollar university lab?
It completely flips the script. Professor McGraw's quote on this is powerful. He said the project has liberated students to do things that they never thought that they could, conducting research in their own yards.
That is a massive statement. It's about democratizing access to scientific inquiry itself.
It is. It removes the need to be physically close to a campus. It removes the financial burden that often comes with dedicated lab access.
Right.
Just think about the implications for, say, non-traditional students, or working parents, or people living far from major research universities. This model lets them engage in high-level research while still managing their life.
It makes the experience accessible to a much broader group of people.
A much broader socioeconomic and geographic cross-section. And this isn't some temporary thing for McGraw. He's been working with online students for over a decade. He's committed to this model.
It also challenges how we view the data itself, right? Because when your research is decentralized like this, gathered by hundreds of little units all over the world,
You create a massive data set that a single campus lab could never, ever replicate.
the collective power of all those localized, hyper-specific data points suddenly becomes this incredibly powerful tool for large-scale analysis.
Absolutely. They aren't just getting data on one population of Java sparrows in one place. They're getting simultaneous comparable data on behaviors across 8 totally different ecosystems.
Which lets you spot the bigger patterns.
Broader ecological patterns and anomalies that would be totally invisible in a single location study.
So to wrap up this deep dive, what we've seen is this fusion of AI, a simple camera, and, a backyard bird feeder. And this pretty simple stack of technology is now generating legitimate data.
And it's forcing students into those necessary scientific pivots we talked about.
Right, and giving them real-world research experience, whether they're in Virginia or Costa Rica.
Yeah.
The takeaway really isn't just that some birds are aggressive.
Right.
It's that the very boundaries of the laboratory are dissolving. They're being replaced by this hyper-local, decentralized scientific inquiry.
And that raises a really important question for you, the listener. If these students can gain critical thinking, software management, and experimental design skills, the cornerstones of any scientific career, just by observing a territorial sparrow or outsmarting a squirrel.
Then what else is out there?
Exactly. How many other seemingly small, localized phenomena around the world are just waiting to be unlocked by accessible technology and some remote curiosity? What foundational research skills could you learn just by observing the environment right outside your window? Maybe the next great scientific finding is happening in your own backyard right now.